Hey guys, so today we're looking at 8.4, which is going to talk about a volume, specifically the disk and washer method. So if a region on a plane is revolved about a line, the resulting figure is a solid of revolution. So what we're doing is we're kind of taking this rectangle here and we're rotating it around the axis. And so it ends up making this cylinder shape right here. So think about making a cylinder. That's what we're doing. The line that it's revolved about is called the axis of revolution, and the simplest such solid is a right circular cylinder or disk. So this is the disk method, which is formed by revolving a rectangle about an axis adjacent to one side of the rectangle. So if we're talking about the volume of a disk, or we could even cross that out and say, let's talk about the volume of a cylinder. I cannot spell, goodness. Cylinder. So the volume of a cylinder is pi r squared h. So what we are doing here, and I see my typo over here as well, so cylinder. So what we're doing here is we need to figure out what's our r and what's our h. So if we are looking at our h, that's going to be our w. That's going to kind of be the width that's happening here. And our r is right here, our radius. So our r is basically whatever our function is. And our height or width, because we're kind of looking at it on its side, is going to be whatever interval we're looking at. So it's going to be from x1 to x2. And so that's kind of how we're going to come up with this formula here. So the following diagrams represent how the volume of a plane region rotated around the x-axis, or sorry, the axis of revolution, in this case the x-axis, can be found. So that's kind of what I was talking about right there. We're going to take a bunch of rectangles, like a Riemann sum, and add up all those rectangles, and then that's going to kind of get us our integral that we're looking at. So real quick, I've got a little video from YouTube that will kind of show us what I'm looking at here. And so this is kind of what's happening. Oh, come on. It won't let me make it full screen. But you're rotating it around the axis, so it's making that shape there. So you rotate it around the axis, and that's how it's making a 3D shape that we are going to try and find the volume of. So that's what we're doing here. So the equations that we're going to look at are disk method formulas. Remember, we're talking about our pi r squared h, that volume of a cylinder. So we are going to have the pi in front. Our r squared is going to be inside the integral. And how we're going to deal about the h is that's going to be our bounds for the integral. So just like in our area, you can do it in terms of x, or you can do it in terms of y. So remember, x is going to be pi, our integral from a to b, of top minus bottom squared dx. So that radius is the top part minus the bottom part. And this one is dealing with x values. If we wanted to do it in terms of y, we have pi, the integral, they use c to d, so those are the y values. And this time it's going to be the right minus the left squared dy. So the right minus the left gives us our radius. And this one is, of course, y values. So let's stop talking about it and let's actually set some of these up. So number 1 through 3, we're going to set up the integral that gives the volume of the solid formed by revolving the region about the given axis. So we're not actually going to solve these yet. We're just going to get some practice setting them up. So we're talking about this y equals a negative x plus 1, and we're going to revolve it around the x-axis. So what we are looking at, if we're talking about the x-axis, that's going to be a top minus bottom. So I'm going to have pi, the integral from a to b of the top minus the bottom squared dx. So my top is that negative x plus 1. My bottom is 0. And then we also need to figure out what a and b are. So how far are we going from the left and to the right? So we're going from 0 to 1. So a is going to be 0, b is going to be 1. We've got all of our pieces. Let's plug it in. So I'm going to have pi, the integral from 0 to 1 of my top, which is a negative x plus 1, minus the bottom, which is 0. And that whole thing is being squared, and then put a dx on the end. So if we wanted to clean it up, we could write it as pi, the integral from 0 to 1 of a negative x plus 1 squared dx. You don't technically need to write that minus 0. And then that would be the integral that you would go through and either use your calculator to solve or solve by hand. All right, let's look at number 2 here. Let's do this one in red. So once again, we're going about the x-axis. So that's going to be another top minus bottom. So my top is that square root of x. My bottom is once again 0 because it's right on the axis. And my a, we're starting at 1, and my b, we're going to 4. That's the section that we have blocked off right there. So same thing, pi, the integral from a to b of the top minus the bottom squared dx means I'm going to have pi, the integral from 1 to 4. My top is the square root of x minus the bottom of 0 squared dx. So pi, integral from 1 to 4 of the square root of x squared dx. Clean it up a little bit, and that is the integral that we're looking at. And let's set up one where we're going around the y-axis instead. So this time we're going to go about the y-axis. So that means that I'm going to do a right minus left, and I need to get everything in terms of y. So if I have that y is equal to x squared, I can square root both sides and get that x is equal to plus or minus the square root of y. But if you look right here, we're only looking at the positive side. So I'm going to say that my right is that x is equal to the square root of y. Left is when x is equal to 0. So there's my right there. There's my left right there. And this time when we're looking for our c and d, we're looking how far down does it go and how far up does it go. So we are going from 0 to 4. So pi, integral from c to d of the right minus the left squared dy. So I'm going to have pi, the integral from 0 to 4 of my right, which is the square root of y, minus my left, which is 0 squared dy. So pi, the integral from 0 to 4 of the square root of y squared dy. And of course, you could keep simplifying that and go and take the integral, but we're just practicing setting them up right now. Something that is important to note, it's not always going to revolve around an axis that we're touching. So it could revolve around a line, let's say some line over here. So then that means that there's a gap in our cylinder. So what do we do if there's a gap in the cylinder? So let's do a quick refresher. Going back to your geometry and algebra junior high days in high school. So Timothy's putting together his science fair project and wants to use volume and mass measurements to determine if various objects will float in varying densities of liquid. His first object is the pictured drive socket below. It is easy enough for him to determine the object's mass with a scale, but he must calculate its volume. So he obtained the following measurements with a tape measure. The radius from the center to the outer rim, so from the inside to the outer rim, is 0.9 centimeters. And then the radius from the center to the inner rim, right there, is 0.3 centimeters. And the height, the entire height right there is 2. So to find the volume of the drive socket, we're going to take the volume of the whole cylinder, and then we're going to subtract the hole that's in the middle of it. So we're going to take the total volume and we're going to subtract the inner volume. That's how we would go through and solve this problem. So we'd have a pi, let's do capital R squared h, minus pi lowercase r squared h. So the total, the big radius minus the small radius. And that's what we're going to do here, and this is called the washer method. So you're going to take the big outside part and subtract the little inside part. So this is what happens if there's a gap there, if it's not touching where it revolves around the axis. So I once again have a little video, so let's click on this video maybe. Oh, I got to move the pen off, that's what it is. So we're looking at something very similar here. We've got our equation, and we've got another equation that's going to come through. And so we've got a little gap where we're revolving. We're only going to take that little section from 0 to 4. And if we try and revolve that, you can see there's like a little hole in it. And so that's what we're doing, is we're trying to figure out how to find the volume with that little hole in between it. And it makes kind of a washer shape. So there you go, that's what it's looking like. Okay, so here are our formulas. We've kind of already talked about it, but we are going to take the big radius, so that r, so that's going to be a big top minus bottom squared, and then the inner radius, which is a lowercase t minus b squared. Note the b will be the same, the t is what's going to change. And then if we're talking about going around the y-axis, so that's going to switch it to y values, then it would be a big r minus l squared and the lowercase r minus l squared. So we're talking about big versus small, and then also your formula for x's and your formula for y's. So let's get some more practice setting up some more integrals. So set up the integral that gives the volume of the solid formed by revolving the region about the x-axis. So we're revolving it around the x-axis right here, so that does mean it's a top minus bottom, and there is a gap. Notice that our region that we're revolving doesn't actually touch the x-axis. So I need to find my big R and my little r, and our big R is going to be the uppercase T minus b. Our little r is lowercase r minus b. So big top, little top, and our bottom is going to be the same. And in this case, our bottom, okay, come on. There we go. Our bottom is just 0 because it's the x-axis. So the big top is our quadratic, so that's going to be that 4 minus x squared over 4. And our little top right here, because we're basically taking the big revolution and then the smaller revolution, is that 2. So it's just 2. Geez, what's going on with my pen? 2. So if I'm going to take pi times the integral from a to b of big top minus bottom squared minus little top minus bottom squared dx, I'm going to have pi, the integral. We're going from -3 to 3, so -3 to 3 of the big one, so 4 minus the x squared over 4 minus 0 squared, minus my little one, which is just going to be 2 minus 0 squared dx. So cleaning that up a little bit, we could have pi, the integral from -3 to 3, of 4 minus x squared over 4 squared, minus, well, 2 minus 0 is 2, and 2 squared is just 4. So that would be our integral that we would then go through and solve. And let's do another one here. So if I'm looking at number 5, once again, we're revolving around the x-axis, and notice that there's this gap here. So we are going to do top minus bottom. There is a gap. So I need the big top and the little top. So if I'm looking at this, the big top is just my x squared, and the little top is the x cubed. It's kind of hard to tell because they intersect pretty closely, but that's what our big top and our little top is. And then we're going from 0 to 1. So I'm going to have pi integral from a to b of top minus bottom squared minus the inner top minus bottom squared dx. So pi, the integral from 0 to 1 of my big top is x squared. The b is what we're revolving around, which is the x-axis, so 0 squared minus the little top, which is my x cubed minus the same 0 squared dx. So pi, the integral from 0 to 1 of x squared squared minus x cubed squared. And we could keep going and simplifying that, but we'll stop right there for now. Okay, so let's get some more practice. Number 6 right here, it says set up the integral to find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the given lines. So let's start by kind of drawing a picture. That's always going to help us out here. So I'm going to draw my graph over here, and I've got y is equal to the square root of x. So that's going to look something like that. Y is equal to 0, which is just our axis, and x is equal to 4. So I'm going to go ahead and label that point's 0, 0. If x is equal to 4, that's going to be 4, 2. Just going to go ahead and label those. And for A, we're revolving around the x-axis, so we're revolving around right here. So that's going to be a top minus bottom. And there is no gap, so we're using our disk method. So we're just going to have pi, the integral from a to b of top minus bottom squared dx. So pi, the integral from 0 to 4, using my x values, because this is dealing with x. And my top is that square root of x. My bottom is the axis 0 squared dx. And we'll just leave it there. We will, I'm going to trust that you guys know how to solve these integrals, and we will stop right there. Lost my train of thought for a second. Okay, let's look at B. So B is revolving around the y-axis. So this time we're going to deal in terms of y. And this one, we're going to have a right minus left. And it's not flush against that. So that does mean we have a gap, and we are using our washer method. So the first thing that I want to do is that if I have y is equal to the square root of x, that would be the same as x is equal to y squared. So I'm going to go ahead and switch that so that we've got our y part that we need for this. So we're going to look at pi, the integral from c to d of big R minus L squared minus little r minus L squared dy, because there's a gap. So the big R, the furthest right, is actually our line right here, which is our line x equals 4. So I'm going to have pi, the integral. I'll come back to the bounds in a second. It's going to be 4 minus 0 squared minus, and then my little radius is that square root of x, which we changed to y squared minus 0 squared dy. And remember, we're talking in terms of y. So my bounds are the y values, the 0 to 2. And that would be the integral. Like I said, you could simplify it more, but I'm going to trust you guys know how to do that since we've been doing it since the beginning of the semester. Okay, new color. Let's do some purple for Richardson High School. The line x equals 4. So if we have x equals, that's going to be a vertical line. And that is our vertical line x equals 4 right here. So once again, it is going to be a right minus left, but this time there is no gap. It touches that x equals 4, that line. Go ahead and make it purple right there. So since there's no gap, we just need to do pi, the integral. Since we're talking about y, our bounds are 0 to 2. The furthest right is that 4, and then our left is minus that square root of x. which we changed to y squared. Squared up there, and then dy. So there we go. There is that part C. And last part, part D, we've done blue, green, purple. Let's do, how about orange? It's my least favorite color, but we can do some orange. We're talking about the line y equals 6. So that's hoi, that's going to be a horizontal line going across at 6. So that's going to be up here. And we're going to rotate around that. So that one is going to be a top minus bottom, and there is a gap. Nothing touches that at all. So we're going to have pi, the integral from a to b. So this time we're back to our x's, which are 0 to 4. And we need to do a big top minus bottom and a little top minus bottom. So if I'm looking at this, my top is that line 6. So I'm going to do 6 minus, and that's going to go all the way down to our very bottom, which is our axis. So 6 minus 0 squared minus. Then my next top is my square root graph. So we're doing like the big rotation and then the smaller rotation. So the smaller rotation is that square root of x minus 0 squared dx. So that would be our integral that we would look at for this problem. Okay, we've got a few more that we're going to look at. And remember, we're just practicing setting up these integrals. I know that you guys know how to find an integral, and actually a lot of these you are going to be able to use your calculator on. If you're looking at an AP test, these questions tend to be on the calculator multiple choice section. So let's look at number 7 here. So set up the integral to find the volume of the solid generated by revolving the region bounded by the graphs of the equation about the line y equals 4. So let's draw our graph. We've got y equals x, which is just that line right there. Y equals 3 is going to be a horizontal line going across at 3, and x equals 0. So we're looking at this shape right here, and we want to revolve it around y equals 4, which is actually going to be this horizontal line up here. So it is a top minus bottom, and there is a gap. So pi, the integral, and we're going to have a big radius minus a small radius with a dx, because it's a top minus bottom. So let's find our bounds. If it's just a line, that means this point is 0, 0, and this point is 3, 3. So we're going to go from 0 to 3. Our big top is going to be the 4 minus our bottom this time is that x. So that's that big revolution here. And then we are going to look at the top again, which is still the 4 minus the bottom. So this is our smaller revolution here, and that one's our 3. And that would be our integral. Let's look at 8. Set up the integral to find the volume of the solid, same directions, but this time we're looking at x equals 6. So let's draw our graph. Here's the graph. I've got the same y equals x. Then I've got y equals 0 and y equals 4. So 1, 2, 3, 4, 1, 2, 3, 4. It's going to go through about right there. And x equals 6. So 4, 5, 6 means that that's going to go through about right there. So this is the area that we're talking about. And we want to revolve that around that x equals 6. So this one is going to be a right minus left, and there is no gap. So I'm going to have pi, the integral for my bounds, and then just the 1 radius squared dy, because it's right minus left. So the furthest right is that x equals 6. So I'm going to do 6 minus, and then our left is our line, which is y equals x. We want the y part, so 6 minus y. And there's our integral. All right, number 9. So set up the integral to find the volume generated by revolving the region around the x-axis. So let's draw our graph. I've got 1 over the square root of x plus 1. I don't know exactly what that's going to look like, but it's going to kind of come down like this. If I've got 0, so 1 over the square root of 0 plus 1 is equal to 1 over the square root of 1, which is just 1 over 1, which equals 1. So I know this point is 0, 1. Then I've got y equals 0, x equals 0, so those are my axes, and then I'm going over here to 3. So I'm looking at this area right here, and if I plug in 3, I'm going to have 1 over the square root of 3 plus 1, so 1 over the square root of 2, the square root of 4, which is 2, so 1/2. So I know this point right here is going to be 3 1/2. But this is going around the x-axis, which is a top minus bottom, so I don't even need that y value, and there is no gap. So I'm going to have pi the integral 1 big radius squared dx, because it's a top minus bottom. So my top is that 1 over the square root of x plus 1. The bottom is my axis of 0, and we are going from 0 to 3. So there's my integral. So what's really going to help you when you're setting these up is drawing a picture, seeing what's happening, and then figure out if it's a disk or a washer. So if it's a disk, you're just going to have one thing squared. If it's a washer, you're going to have to subtract the 2 like we did in 7, and then start filling in the bounds and what you're subtracting inside that 1 squared part or the 2 squared parts. All right, 10. Set up the integral, all the same directions, but now we are looking at the y-axis. So let's draw our graphs. If I have y is equal to 3 times 2 minus x, that's the same thing as y is equal to 6 minus 3x. So I'm going to be up 1, 2, 3, 4, 5, 6, and my slope is down 3 over 1. 1, 2, 3, 4, 5, 6, and I just put that point in the wrong spot. Should be right there, and then it's going to hit right here. So there's my little triangle. So this is the area that we're looking at, and we're revolving it around the y-axis. So that's going to be a right minus left, and there is no gap, so I'm going to have pi, the integral, and 1 thing squared dy. So my bounds are going to be how far down it goes, which is starting here at 0 and going up here to that 6. And my furthest right is my line, but I need it in terms of x. So I'm going to take that y is equal to 3 times 2 minus x. I'm going to divide by 3. So 1/3 y is equal to 2 minus x. Subtract the 2. So 1/3 y minus 2 is equal to a negative x. And then I need to flip all those signs. So I end up with x is equal to a negative 1/3 y plus 2. So I'm going to have a negative 1/3 y plus 2. And then my left is just the axis, so it would be minus 0. And so that would be the integral that we would then either plug into our calculator or go through and solve by hand. All right, last question for this video. It's the same directions and we're going about the x-axis. So let's draw our graph. If I'm looking at the sign of x, that makes my wave like this. Goes through the point 0, 0. Then we're going with y is 0, x is 0, and then also x is pi, which is once again where it comes down and touches 0. Sine of pi is 0. And we are revolving around the x-axis, so this is a top minus bottom. No gap. We're looking at this area right here. So pi integral 1 thing being squared and a dx because it's a top minus bottom. So my bounds are from 0 to pi. My top part is the sine x, and my bottom part is the axis, which is the 0. And there's my integral. So we did a lot of setting up integrals. In your homework, you are going to have to solve some of them, but you can use your calculator to help you out if you would like to. And that is it for this video. So remember, if you have any questions, you can email me, ask me in class, come to tutoring, and you guys go ahead and get started on the Go Formative homework assignment. You guys have a good day.